Zenka Matia. I'm a teacher for physics and mathematics. So today we are going to have our physics lesson. We are going to concentrate on Hooke's law. So firstly, let's go through our notes, the short notes that I have written on the board. What does Hooke's law state? That would be the question. Hooke's law states that the extension of the spring is directly proportional to force applied, provided that the limit of proportionality is not exceeded. So we have the equation here. The equation reads as follows. We are having F equals to my negative kx. So one would ask, what do F stands for? The negative sign and the k here and the x. But remember, in physics and mathematics we use the variables to represent numbers. So let's explain our equation here. We are saying that in the equation we have the F. The F would stand for force. The force that we know that the SI units of force are newtons. Then we have the K. The K is the constant. This time around we are going to look, or we are going to study how the spring works. Therefore the constant would be the spring constant. The SI units for the spring constant would be newtons per meters. Again we have the x. The x which would mean the extension in meters, and we know that meters represent the displacement or the distance in physics. But you should be aware that in other books, while reading, you might find that the equation is written in the different form that we have written it. For example, we could have F equals to negative ke. This time around, that says the e in the equation is the extension because we have not used x. Thank you. So moving on, we are saying that the spring constant is the measure of how stiff, of the stiffness of the spring. Therefore, we want to know how stiff is the spring. Then we will be told, or we'll conclude that by calculating the spring constant being the K. And you have to note this. It is different. The spring constant is different for different springs. And for the materials, the material that has made up the spring is more important and is the one that causes the spring constant to be different. So moving on, we are saying that the larger the constant, the stiffer the spring, and the more difficult it is to stretch. So that says here we are saying spring, the more difficult it is to stretch the spring. Why are we saying that? Remember what we said. We said that the spring, the extension is it is directly proportional to the force applied. And again, if we are saying that the larger the spring constant, the stiffer the spring, and the more difficult it is to stretch the spring. What do we mean? This is what we mean. If we have the larger constant, we are going to multiply by the bigger number. And we know that the more we multiply or we add, we have the bigger number multiplying a certain number, we will get the bigger result. That says we will be multiplying with k on this side, and we will be multiplying the extension with k, the bigger constant. That says our force will increase directly proportional to the constant. As the constant increases, the force needed to stretch the spring would be large. Thank you. So Moving on, we are saying that the negative sign in Hooke's law, we can notice that we have the negative sign right here. So the negative sign in the equation, it means that the force applied by the spring opposes the spring displacement. What do we mean by the displacement? Remember, in physics we have the two types of quantities, being the vector quantity and the scalar quantity. And if you can remember well, we have classified, the force is classified under the vector quantity, of which we say the vector quantities are those quantities that have a magnitude and the magnitude and direction. So does force. Therefore, to note the direction in physics, we use the negative sign or the positive sign. That says, now we are saying that we have the positive displacement being given. Then the negative sign only means that the force that is being applied is going to be in a different direction as the displacement. Remember, and again, the displacement is also classified under the vector quantities. That says it has the direction and the magnitude. So let's have few examples. If we are required or asked to calculate the spring constant, let's take, for example, number 1. We are aware that we are given the force applied, and we are given the spring extension. That says in our equation, let's first start with the equation. Then we are given the force, and we are aware that we are also given the spring extension. That says we are given the x and the f in the equation. So for us, we would, this time around, we have to calculate the spring constant. That says for us to get the spring constant, we have to do the mathematical procedure by making k the subject of the formula. Therefore, making k the subject of the formula, we are going to divide by k both sides, because k has multiplied x on the right side. No. Excuse me. We are looking for we are making k the subject of the formula. Then that says we should divide by x, because we want k to be left in the right hand side alone. And we are having the negative here. That says it would be correct or wise for us to divide with the negative x, so that we are going to be left with k only. And therefore, the x, negative x, will cancel, and our equation will be k equals to negative f over x. And now we can substitute our given values in the equation, so that we can get the spring constant k. So substituting, we will be having negative, and we are given that the force is 3 newtons. Then the extension is given as 3 newtons per meters. No, it's 15. Sorry, the extension is 15 meters. It's 15 meters. So we are saying, now we have substituted our values. So what's left for us is to calculate. When calculating, we will get negative 1 over, we know that 3 into 3 goes once, into 15 it goes 5 times. We are just simplifying. Hence we will get newtons over meters, of which in our notes we showed that the spring constant has the units newtons per meters because we are dividing the newtons with the meters. So let's move on to example number 2. This time around we are given the spring constant and the extension. So that says this time around we would have to calculate the force needed to stretch that spring. So let's go. We first put our equation right here. Then you would be aware that this time around we have the force equals to negative kx, and we are given the k being the spring constant, and we are given the extension being in meters. So all we have to do is to just substitute our values. The k given is 3 newtons per meters multiplied by the extension being 4 meters. Then when multiplying we will get negative 3 times 4, we get negative 12. So we know that the force, the SI units for force is newtons, but how do we go? But now we are having newtons per meters multiplying 4 newtons, 4 meters in fact. Therefore we would be saying it's 12 newtons per meters multiplying meters. Mathematically we know that we have this type of this kind of a setup. If we are multiplying a newtons per meters by meters, we know that m is over 1 because everything divided by 1 we get that number. So if you could see, we are able to say, to shift and say 12, and then because we know that multiplication is commutative and is associative. That means we could just swipe or start or multiply from any point. We can start from any point or divide from any point. That those rules allows us to swipe m and bring it under m and bring one under n. That says m would cancel the m and we will be left with 12 newtons. That's how we will get the units for force in our problem. So now I would like you to do example 3, and you should be aware that if you are given the force and the spring constant, that says this time around you are required to calculate the extension. So for you to calculate the extension, going back to your equation, you will have to make x the subject of the formula, or the extension the subject of the formula. So again, let's look at example 2. You would be aware that we are having negative 12. So this says that our force would be on the opposite direction of the extension, just like we have just stated here, that the negative only, or it just shows the direction of the force applied. That says if we have the spring, if you have the spring and the mass being held, mass in m, then the mass would be stretching the spring in the downwards direction. That says the force is going to be in the opposite direction, being the upper direction. Thank you.